Okay, hi. Let's get through this review here. Um, if you're watching this, hopefully well, my kids are home. I don't know if you just heard that, but it could get wild here. We'll see how this goes. Um, okay, so for this first question, what I'm trying to reinforce for you guys is the idea that certain angles show up in certain positions around this coordinate plane, right? So what I've tried to draw here is an angle in this position that is closer to the x-axis than it is to the y-axis. And the only types of angles that are closer to the x-axis than the y-axis are these four angles. And every single one of these angles is a pi over 6. Okay, so if you notice, coming back to here, only one of these angles is pi over 6. Okay, so process of elimination, this has to be A, right? It's pi over 4, pi over 3, pi, and pi over 2. Pi over 2 angles, the ones that are labeled, only show up straight up or straight down, right? Even the ones that are over here, pi and 0 or even 2 pi over here, those are variations of pi over 2, but they're not labeled as pi over 2. Okay, so when you come back here, there's only one of these that's pi over 2, and it's this one. So that would have to be E. I'm sorry if I'm going out of order for you. Let's get this other easy one out of the way. We have a line over here that we're labeling as C, and we know that this is pi. We know that this is 0. So if we rotate from here to here, that's pi. If we rotate back to here, that's 2 pi. If we rotate back again, that's another pi. So this, what we can call the negative x-axis, is odd variations of pi. So it's pi, but it's also 3 pi, right? This line, if we rotate, if this is 3 pi and we rotate over to here, this is also 4 pi. If we rotate over to here again, this is also 5 pi. So you see where this is headed, right? This has to be C. This is the only angle where it's just pi. Okay. Let me clean this up a little bit. Keep going. We've talked about this in class at length as well, that our pi over 4 angles, any angle that's pi over 4, I've been calling these the half quadrant angles. Half quadrant meaning cutting literally right through the middle of the quadrant. As we can see, we're only left with two choices here at this point. B, definitely not. D, as close as I could estimate, cutting right through the middle. So this pi over 4 angle has to be D, which leaves the angle here, B, which is closest to the y-axis. The angles that are closest to the y-axis are this angle here, this angle here, this angle down here, and this angle down here. And all four of those angles are pi over 3 angles. So this would be B, right? Is it 32 pi over 3? You could check if you wanted to. You could come over here, right? We talked about this in class. You could come over here and you could start counting your pi over 3s. Like here's 1 pi over 3. Here, that's 1 pi over 3. Here's another pi over 3 right here. Here's another pi, right? We talked about counting by pi over 3s, but by process of elimination, and the point that, again, like I started with, that I'm trying to hammer home here is the idea that certain angles in these positions closer to the x-axis, this has to be some variation of pi over 6. Closest to the y-axis has to be some variation of pi over 3. I don't know which one, but there's only one option over here. And I'm not going to put multiple options when it comes to the quiz. I'm just trying to get you to realize angles that cut right through the middle of the quadrant, this has to be some variation of pi over 4, right? This has to be some variation of just pi. This has to be some variation of just pi over 2, okay, based on where they're located with respect to the axes.